elc138 worksheet 17. Find the fault in the instructor built circuit. Wires attached to nodes will be the only access. So your fault V1 to 0 is going to equal 9.5. V from 2 to 0 is going to equal 9.5. And V from 3 to 0 is going to equal 9.5. So you tell me what the fault is. Consider the circuit. So here's another circuit. Build it very carefully and come up with the normal conditions. Now, when I talk about node 1, by default, it's node 1 to 0, node 2 to 0, node 3 to 0, node 4 to 0. Up above, I actually put in the zeros. So it'd be node 1 reference to 0, 2 reference to 0, 3 reference to 0. Okay? So that's what I'm looking for, the node voltages. Whoops. Find that save. Okay. The node voltages, normal, and then with R6 shorted, R5 shorted, R3 open, and R1 shorted. Okay. 8 and 9. What resistor must be in series with a 2.5 milliamp 75 ohm meter movement that is sourced by a 1.5 volt battery in order to make it an ohm meter? Ohm meters. So that's the next thing. So we're going to take the same meter movement and we're going to make it an ohm meter. Okay. So 2.5 milliamp 75 ohm meter movement means this will only take 2.5 milli. And it has 75 ohms of resistance, but I have a 1.5 volt battery. So I have to come up with a resistor to make that, to limit the current in that circuit to 2 milliamps. So if I take 1.5 and divide it by 2, milliamps, I'll get a ohmic reading. That ohmic reading minus my 75 ohm reading is the reading I'm looking for in terms to make it a ohm meter. Now, ohm meters source their own power. They have their own battery. And this is in the course material. He talks about how to make an ohm meter in depth. I do recommend you go and you read that section because it's very good. Okay? So you need a resistor in order to make sure the current does not exceed 2 milliamps, because that's what's going to go through your meter movement. And ohm meters will read backwards. In other words, if you have no resistance, you will get full scale deflection. And so normally you set them by shorting your resistors, watching the deflection go full scale, because you have no resistance. And you want that to be your 0 level. Well, there are variations in battery voltages, and so a 1.5 volt battery could be anywhere from 1.6 to 1.5 to 1.48. So since you have a voltage difference, this internal resistor that you figured would have to also change. So what they do typically is they will put a second resistor in there, actually on a potentiometer, so they can, or a rheostat, potentiometer set up as a rheostat, so they can make adjustments. And so a lot of times those meters will have a 0 ohm adjustment. So when you short the leads, if your deflection doesn't go to true 0, you can adjust the 0 ohm to make it 0. and that's usually the first step before using them. And that accounts for the different battery voltages. Anyway, I think you should read that section. Discharge the capacitors on the trainer using a resistor. What's the time constant? Obviously, we can't discharge the capacitors on the trainer using a resistor, but you can figure out what a time constant is. So for 10 to 15, tell me what a time constant is, and how do I come up with it in an RC circuit, or a resistor capacitor circuit. Okay. Measure the capacitances of the trainer with a capacitance meter. That would be like measuring the resistance. They do make meters that will do that. Obviously we can't do it. And then connect the circuit. Verify the voltage across the capacitor 0, charge it, and then what happens? So basically we're setting up a circuit to charge the capacitor and then discharge it. So if we are on position A, we'll charge the capacitor through a resistor. And if we switch it to resistance B, we will discharge that capacitor through the same resistor. So what would the time constant be for that capacitor? 8.8 micro and 200 k ohms. What would be your time constant? Normally, charging a capacitor, we consider it to take 5 time constants. Okay, so 1 time constant is what you calculate with your R and your C, and then 5 time constants is what we get in terms of charging and discharging time. And so this was meant to be a intro to this. And then my indicator light. This circuit would charge a capacitor, and then you could select to open the circuit from the battery source, and then the light would stay on while the capacitor discharged through it down to a certain point. And so they were wanting to show you that capacitors actually store energy, and that's a pretty good thing. I may do a video on the trainer, I may not, I don't know. Diode testing on a digital multimeter shows what? So if you were at school and you put a diode across your digital multimeter and you put it on diode, it would actually show you the voltage drop of the diode. Doesn't show you resistance, it shows you the voltage drop. So I think he talks about that in his coursework. Currents below 1 milliamp are typically hard to read with an ammeter. Now this is where we're getting away from breaking the circuit and putting an ammeter in series. We want to go to an easier way to do things, because you learn the hard way and then you get the easy way and you go from there. So one option is to measure the resistance of the resistor and then the voltage drop across it in the circuit. How is the current obtained? Well, it'll just be Ohm's law. If you know the voltage drop across a resistor and you know the value of the resistor, can you tell me the current through it? And Ohm's law would let you know. So then I give you an example. What do capacitors do? How do you measure the capacitance? You should probably do it with a meter. What capacitors do is they store energy, and they store it in the form of an electric field. There'll be another device that will store energy in the form of a magnetic field later. It's called an inductor. And then for 20, we just went over meters last time, so here is an example. You've got 3.5 vertical divisions with an oscope set at 3 volts per division. What's the RMS voltage? And it is a sine wave. Anyway, this is worksheet 17. Once you get a grade for worksheet 17 in Blackboard, you will be able to see 19 through 24. So you'll be able to see the rest of the worksheets. You can sort of go ahead, plan ahead, look ahead, plan ahead, and I'll see what I can do in terms of videos. And I thank you for watching.